Well, hello, my little triglets. How are we all today? All right, we are going to talk about log functions today. So it's section 4.2, log functions. And don't forget about the fun involved. All right, log functions are inverses of exponential functions. Okay, so sometimes we want distance in terms of time instead of time in terms of distance, so we have to use the inverse of functions. To find an inverse, in the past, what we've done is we switch x and y and then solve for y. So in our case, if I have an exponential function, y equals b to the x, I switch x and y, so I have x equals b to the y, but how do we solve for y? How do we get that alone? Um, we're not used to that because it's an exponent. So this is where logs come in, because x equals b to the y is the same as saying y equals log b to the x. Okay, so this base becomes the base number down here, and this now becomes part of the process where this becomes the answer or the isolated term. Okay, so let's try a couple of these. Let's say I have 3 equals log 7 of x. So the equivalent of that is we take the base and then we set it to this exponent, and then this becomes our isolated part. So this can be any letter, X or Y or Z or A, anything, but that's how you would set it up. And then you can figure out what 7 to the third is. Let's try another one. Log base 4 of 26 equals Y. So now I have different things, but you always start with this base number. So it's 4 to the answer to the y equals 26. Okay, so we're just practicing going back and forth between log form and exponential form. So let's try exponential form and turn it into the log form. So what used to be the base, or what is the base here, has to be the log base over on this side. So log base 2, the answer now goes here, and then the exponent now becomes our answer on this side. Let's try another one. B to the third equals 27. Okay, so this number here becomes your log base. So log of B, the answer becomes this part, and then your exponent becomes the answer. So all I did there was go back and forth between log form and exponential form. All right, the next thing is if it says, let me start that over. That wasn't a very good word, evaluate. If it says to evaluate, okay. I'm having technical difficulties here. All right, if it says to evaluate, what you have to do is set it equal to x, and then you can solve it. So if, for instance, if it says to evaluate log base 2 of 16, log base 2 of 16, we don't know. Base 2 is not on our calculator, and we'll talk about base 10 in a few minutes. But log base 2 of 16, we set it equal to x, and now I can change it to exponential form. So I can say 2 to the x equals 16, and then you can actually figure it out. You know, you can do it in your head. 2 times 2 times 2 times 2 is 16. So 2 to the fourth is 16, so we can say x must be equal to 4. Let's try another one. How about log base 4 of 4 to the fifth? Okay, we have to evaluate that. So I'm going to set it equal to x. So 4 to the x equals 4 to the fifth. Well, because these are both 4s, that means these must be equal. So I don't really have any figuring out to do. I just say, well, they're in the same position. X and 5 are the same spot. So x equals 5. All right, let's look at some graphs. Let's say I have y equals 2 to the x graph, and we do a t-chart. We pick a bunch of numbers, 0, 1, -1, 2, -2, and we get our graph to look something like this. Okay, then I'm going to do y equals, let's do log base 2 of x. So we have a different setup here. It's going to be the inverse. So what happens is we have a diagonal line here. This is the x equals y line. And this graph of log base 2 of x is just the mirror image of this. So if you find points, let's say this point was 3, 1, then this point up here is going to be 1, 3. See how x and y switch? So that's what's happening, is the log form is the inverse of the exponential form. Okay, and also just kind of a side note here, the domain of 2 to the x becomes the range of log base 2 of x. So they switch, and that makes sense because here's my domain is 3, and the range is 3 in the other graph. So it switches, okay? And then that goes the other way too. The range of 2 to the x is the domain of log 2x. And if you want to look at some more graphs in your book, page 461 has more graphs to just take a look at and see how they're acting with each other. All right, I said earlier we talk about base 10. Base 10 is called the common log, and it's the one that's on our calculator. It's not usually written when you see a problem. So if you just have log of 5, if there's nothing here, then you know it's base 10. And you can fill it in if that helps you figure things out. So if I wanted to figure out log of 5, I could actually do this on the calculator because our calculator is all in base 10. There's also another log. It's called the natural log. And that has base E. Okay, base E is also on your calculator. It's under ln, natural log. So we can figure those out as well. So those two you can do on your calculator. If it's something other than those two, we have to change its form. And again, we'll talk about that later. All right, one little extra note here. When you have a domain, which is really the input or the x value, it has to end up positive. Okay, you can't take the log of a negative number. It has to end up positive. So, for example, if I have log of 3 minus x, and I want to know its domain, meaning what am I allowed to put in for x? So what is allowed? So if you think about that, if this has to be positive, then I can put any negative number in for x. So any negative, because a minus a negative would make it positive, or I can put up to a 3 in there, because 3 minus 3 is 0. Up to a 3, not including the 3, but up to the 3. So the way we'd write that is the domain is from negative infinity, because that's any negative number, all the way up to a 3. Now I need to put a curve here because that means not equal to 3. Everything up to 3, but not equal to 3. So 2.999999999 is good, but 3 is not good. Okay, another way to write it is something like, you could say x such that x has to be less than or equal to 3. So that these two things mean the same. Okay, whichever way you want to do it is okay with me. There's interval notation, which is the top one, and set notation, which is the bottom one. Okay, so same deal. If I have natural log of x minus 3, this time we have x minus 3 instead of 3 minus x, so this time the domain is going to be, let's do it in this set notation here, x such that x has to be greater than 3. Okay, or what if I had the log of x minus 3 squared? Okay, when you square something, it becomes positive. So if I have to have positive, the only number that's not going to work is 3, because if I have 3 minus 3, that equals 0, and I've got to be positive. 0 is not a positive number. So we can say x such that x does not equal 3. Okay, so it all depends on what's going on. You have to ask yourself, how am I going to make this result positive of whatever you're taking the log or natural log of? Okay, I think that's it for now. Don't forget, Trig Love is out there. All you got to do is look for it. Ta-ta.